Today's lesson is section 7.2, and it's all about dividing powers. So section 7.1, we looked at all the different ways to multiply them. So when we multiply like bases, we add exponents. When we have a power to a power, we multiply. So today we're going to do everything with division. So our first key concept, it says when we divide two powers with the same base, we subtract the exponents. So if you think about it, when we multiplied, we added. When we divide, we subtract. So our first example is to simplify x to the 7th, y to the 12th, divided by x to the 6th, y to the 3rd. So we can rewrite this. I'm going to show you how the rule says we should do it, and then how I like to think about it more logically. So in this case, I would do x to the 7 minus 6, y to the 12 minus 3. Notice how we got rid of the fraction because we're subtracting. So 7 minus 6 is x to the 1st, 12 minus 3 is to the 9th, and notice how both of our exponents are positive. So we would write our final answer as x times y to the 9th. And I bring up the positive exponents because when we subtract, we know that we can sometimes get negative values. Now, here's how I like to think about it more logically. I say, okay, if I have x to the 7th over x to the 6th, where do I have more x's? And I say, okay, I have more up top, so I write my x up top. And then I say, well, how many more did I have up top? Well, I had one more up top. And now if I look at my y's, I had 12 y's up top, 3 y's on the bottom. Where do we have more y's? Well, we have more y's up top, so I write my y up top. And then how many more did I have up top? I had 9. So it means I have nothing down here in the denominator, so we could put it as a 1 because that's how we write any fraction, but without that 1, it would be xy to the 9th. And you might be saying, well, the first way is easier, and I agree, but thinking about it logically when we get into negative exponents, it helps us to not have to work with negative exponents as much. And I will do this one more way, because when you guys had this in pre-algebra, I'm gonna actually use some smaller numbers, so we'll do it up here. So if we had like x cubed over x squared, x cubed means I would have 3 x's in the numerator. X squared means I would have 2 in the denominator. And if we have something in the numerator and in the denominator, the same exact thing, remember they get crossed off. So that's why we end up with just x. And if we do it the other way, it would be x to the 3 minus 2, which is x to the 1st, which is still just x. So take a moment, try the your turn, and then come back and check your work. Okay, so a squared times b to the 7th is what you should have gotten. All right, so now we have power of a quotient, and this reminds me of power of a product rule, because what it says is if you have that exponent outside and you have a bunch of different things being multiplied together inside, that cube needs to go to everything in the numerator, just like before, but also everything in the denominator. So it's still sort of like that distributive property for exponents. So to find the power of a quotient, find the power of the numerator and the power of the denominator. So to simplify this first example, we would get 4 cubed, c cubed, cubed, d squared, cubed, all over 5 cubed. All right, so 4 to the 3rd power, we get 64. Remember, power to power we multiply, so c to the 9th, d to the 6th, and 5 cubed should be 125. And now we just need to double check, can we simplify this anywhere? Well, 64 divided by 125 does not simplify at all, and I have no other letters or variables represented more than once, so that's it. All right, so take a moment. Try the your turn. Oh, I do know. There is something we need to add to this your turn. We are just going to add a squared there. Otherwise, the problem would be done. So take a moment. Now try that your turn and then come back and check your work. All right, so you should have got 9m to the 6th n to the 4th divided by 16p to the 10th q squared. All right, moving right along. This one here is probably the easiest rule. And it says, if you have any non-zero number, so pretty much any number other than 0, raised to the 0 power, it's just 1. So anything raised to the 0 power is 1. So if we look at our example 3, I have all this stuff inside. 12m to the 8th n to the 7th divided by 8m to the 5th n to the 10th. But then I look and see that it's all raised to that 0 power. So my answer is just 1, because all of it's raised to the 0 power. So we can say, 1, we are done. But it's not always quite that simple. So let's take a look at example B. So m to the 0. Now here, this problem, the only thing that's raised to that 0 exponent is just the m. So we can't just say 1, but I can say that m to the 0, well, that's a 1. So I have 1n cubed over n squared. Well, now I have like variables in the numerator and denominator. So I have 3 in the numerator, 2 in the denominator, so that means I have 1 left over in the numerator. So my answer is just n. If we did it the other way, it would be n to the 3 minus 2, which is n to the first, which is just n. All right, so take a moment, try those two your turns, A and B, and then we're going to start looking at negative exponents. All right, so negative exponents, what we're going to look at is our key concept box. It says for any non-zero number a. Okay, so and any integer n. If they have a to the n, it's the reciprocal of a to the n. All right, so that makes it sound real complicated. Pretty much it just says, if I have this, that actually means 1 over 5 squared. So if I have a negative exponent in the numerator, I move that to the denominator and make the exponent positive. It also works the other way. My 5 here in the numerator, think about what its exponent is. It has an exponent of 1, which is a positive 1, so we don't move that. I'm going to keep that up there because that's a positive 1. If I move it, I'm then making it negative. But if we look at this denominator, 2 to the negative 2, if it's negative in the denominator, we move it to the top and we make the exponent positive. And then those two become multiplied together. So this would be, and then there's nothing left in the denominator, just a 1. So I would have 5 times 2 squared, which is 4, and then 5 times 4, which is 20. Okay, this is the one that takes a little bit of practice. All right, so simplify each expression, assume no denominator is equal to 0. So as soon as I see negative exponents, I automatically just go ahead and put my fraction bar, okay? And then I look at each variable individually. X to the 4th, well, it's in the numerator, but it's negative. So that means I need to move my x to the denominator, and that negative 4 becomes a positive 4. Y to the 9th, that's positive, so I don't touch it. It's in the numerator, it's going to stay in the numerator. And then finally, z to the negative 6, well, that's negative, and it's in the denominator originally, so I need to move it to the top and make it positive. And now we need to simplify this, if we can. So I have an x, a y, and a z. None are repeated, so we are good to go. All right, let's take a look at this next one. The first thing I notice is I have 75 divided by 15. So 75 divided by 15, that becomes 5, and that's a positive 5, so that stays in the numerator. All right, and now I have my p's. I'm going to just worry about negative exponents right now. So p cubed, that stays in the numerator. Q to the negative 5, that is going to the denominator and becoming positive. I already took care of my 75 and 15. P to the 5th, that's positive in the denominator, so guess what? It's staying in the denominator, positive. Q to the negative 4, that's in the denominator, negative, so I have to move it to the top to become positive. And then R to the negative 8, that needs to be moved to the top and become positive 8. So now let's simplify everything else. My 5 stays in the numerator. Now look, where do I have more p's? I have 3 in the top, 5 on the bottom. I have more in the bottom, so I put my p in the bottom. And how many more do I have in the bottom? Well, I have 2 more down there. Look at the q's. You have 4 up top, 5 on the bottom. Where do you have more? I have more down at the bottom, but I only have 1 more down there. And r to the 8th, I don't have any other r's, so r to the 8th stays up top. So my final answer would be 5 r to the 8th divided by p squared q. Okay, I'm going to do C 2 different ways. I'm going to do it the way I just did B, and then I'm going to show you how we could do it with just subtracting and then worrying about exponents. So again, I see negative 3 over 30. Now, this negative 3, it's just a normal negative 3. The exponent is not negative. Its exponent is 1, so I am not moving it. Don't let that negative out front start to confuse you. Just think about what we've always done. So that simplifies to a negative 1 over 10. And now x to the negative 6th. Well, that's going to the bottom and becoming positive. Y to the 5th is staying there. Z is staying there. Now in the denominator, x to the 4th stays where it is. Y to the negative 2, that's going to move to the top. And Z to the 5th is staying there. All right, so combine all of your y's together. So y to the 5th times y squared, they're like bases, so we add the exponents. Z doesn't have anything to go with, so it stays. My 10 stays down there. X to the 6th times x to the 4th. Multiply like bases, we add the exponent, so we get x to the 10th times z to the 5th. So what I'm going to do is do it the other way now. Let me get a different color for this. So now I'm going to do it how the rules say, to subtract the exponents. So I'm still going to have my negative 1/10. And I'm sort of going to put all of these off to the side. So then I would get x to the negative 6th minus 4. Then I would get y to the 5 minus a negative 2. And then I would have, oh, I just realized I need to simplify those then. Then I would have z to the 1 minus 5. You know what, I'm going to go back up and simplify these. I simplified everything else but my z's, so that's going to go away, and that's going to be to the 4th. Okay. So now, I still have my negative 1/10. But now, negative 6 minus 4 is negative 10. 5 minus a negative, well, that's a plus 7. And 1 minus 5, that's a negative 4. And now that we have negative exponents, because you cannot leave them negative, now we need to create our fraction again. My negative 1 is up top, my 10 is on the bottom. All of these here, they're like in a numerator. So that means x to the 10th needs to go to the bottom, y to the 7th stays up top, and z to the negative 4 goes to the bottom and becomes positive. So now you can see that those two answers match. So take a moment, try that last your turn, those 3 problems, and then come back and double check your work. All right, so there's all 3 problems. Hopefully I didn't make any mistakes going through here. I just want to double check this last one. A to the 8th on the bottom, b cubed up top, and c to the 12th up top.